So now we'll look at Charles' law, which shows the relationship between volume and temperature. And we're going to do a lab that basically proves Charles' law. That's the whole point of the lab. We'll look at how the volume changes at different temperatures. So over here in this graph, you can see we're plotting here. So volume versus temperature, and you can see it's a straight line. So as you increase the volume, you increase the temperature. So they are directly proportional. And this is called Charles' law because there was a guy named Charles, that's his last name, who was a hot air balloon enthusiast, and he was studying a lot of, he discovered this relationship between volume and temperature. All right, so when you're plotting this temperature, make sure that you're using absolute temperature in Kelvin. So Kelvin temperature is going to be important. You're not going to get the same relationship if you use Celsius, so we need to use Kelvin. And so this is the relationship is basically volume over temperature. So volume 1, temperature 1 is equal to volume 2 at temperature 2. So if I knew 2 volumes and a temperature, I can figure out what the other temperature was. Or if I knew 2 temperatures and a volume, I can determine the other volume. Because the volume over temperature for a particular gas has to be the same, that ratio of volume over temperature. Alright, so we need to remember that equation. That's going to be important. So let's try to use that equation in this problem here. So we have a fixed quantity of gas in a container is cooled from 44. So our T1 is 44 degrees Celsius. Do you guys like Celsius? We like Kelvin. So we're going to add 273 to that to get our Kelvin temperature. And our temperature 2 is 21 degrees Celsius, but we don't like Celsius, so we're going to add 273 to get to Kelvin. If the initial volume, so volume 1 is 3.2, volume 1 is 3.2 liters, what is volume 2? That's what we're looking for, volume 2. So we add up these temperatures. We 273 plus 44, that's 317 Kelvin. 317 Kelvin. And 273 plus 21 is 294 Kelvin. And so now we're just going to plug it into that equation. V over T equals V over T. So V, just make sure you put the right volume with the right temperature. So V1, and it really doesn't matter what you're calling 1 and 2, just as long as this temperature goes with that volume and this temperature goes with that volume. The 1 and the 2 don't really matter, just as long as this temperature is with that volume. So I have volume over temperature, 317, is equal to volume 2, that's what we're looking for, over this temperature, 294. So you can either, now how you're going to solve this is just algebra. You can cross multiply and then divide over there, or if you just multiply both sides by 294, that will cancel. So I'm going to multiply over here by 294. So in your calculator, you're going to do 294 times 3.2 and then divide that by 317. And when you do that, you get volume 2 is like 2.96782, something like that. And how many significant figures do we need? Well, I have 3 here. I started off here with 2, but when I added the 273, I take the least number of decimal places. So now I have 3. I have 3 sig figs here, 3 sig figs there, 3 sig figs there. So I want 3 in my final answer. So I want 2 points. So I look at this one. I want 2, 3. Do I round that up? Yeah, I'll round that up to 2.97. And my units are liters because that is a volume. So this is basically Charles' law. Charles' law is just saying volume over temperature equals volume over temperature. Here's another example. Let's try one more. Let's see. So we have a sample of gas that has an initial temperature. So T1 here, 25 degrees Celsius. Do you like Celsius? No, you like Kelvin. So you're going to add 273 and 25. It's 298 Kelvin. And the initial volume, so V1, is 1.75. At what temperature, so T2, that's what we're looking for, at what temperature, question mark, will the volume be 2.52? These are both in liters. Just do a quick check and make sure your units match. So again, we have V over T equals V over T. So volume 1, I have 1.75 over T1 equals volume 2, 2.52 over T2. And so now we want to solve for this thing on the bottom. So you can cross multiply. If you remember cross multiply, you have 1.75 times T2 is equal to 2.52 times 298. And then I just have to divide by 1.75. There's a lot of ways to do this. So if you thought of a different way to do it and you get the same answer, that's okay. It's just math. And then when you work all that out, you get T2 is like 429 Kelvin. 429 Kelvin. Alright, so V over T equals V over T. It's Charles' law. Again, Charles was the guy who did the hot air balloon. Do you guys know where the first hot air balloon landed in the United States? It was in Deptford, which is kind of cool because it's right around the corner.